While you're reading this sentence, millions of tons of freezing fresh water are secretly pouring into the Atlantic Ocean. This hidden underwater flood is moving at an alarming speed, threatening to destroy the delicate balance that keeps Europe warm. If this giant ocean current stops moving, major cities like London and Paris could soon face winters as cold as the Arctic. Something unprecedented is happening deep beneath the surface of the sea, and scientists are racing to figure out what comes next. If you love exploring the biggest mysteries of our changing planet and want real science without any fake drama, subscribe right now. By hitting that button, you will join a growing community of curious minds who want to stay ahead of the curve and understand the true forces shaping our world. To really understand why the weather in Europe is taking such a dramatic turn, we have to look back at how the continent stayed so comfortable for thousands of years. Europe sits quite far north on our planet. Cities like London and Berlin are actually on the same level as frozen parts of Canada. By all rights, Europe should be covered in thick ice and snow for most of the year. Yet, for all of modern human history, Western Europe has enjoyed mild winters and pleasant summers. The secret behind this soft climate is a massive ocean system that acts like a giant central heating unit for the entire planet. Scientists call this system the Atlantic Meridional Overturning Circulation, or AMOC for short. You can think of it as a vast underwater conveyor belt. It takes warm water from the tropical ocean near the equator and carries it thousands of miles north toward Europe and North America. As this warm tropical water reaches the North Atlantic Ocean near Greenland, it releases its heat into the air. Winds carry that warm air right over the European continent, keeping cities cozy even during the darkest winter months. Once the water loses its heat, it becomes very cold. Cold water is heavier and denser than warm water, so it sinks deep down to the bottom of the sea. Then, it flows all the way back south along the ocean floor to complete the loop. For centuries, this engine worked like clockwork, keeping the climate predictable and stable for hundreds of millions of people. Farmers knew exactly when to plant their crops, and cities built their lives around mild, predictable seasons. But recently, something inside this global engine began to break down, sparking a central mystery that has top climate scientists deeply worried. The central mystery began when researchers noticed that the North Atlantic was not behaving the way it used to. While almost the entire surface of the Earth has been getting warmer over the past few decades, one specific spot in the Atlantic Ocean was actually getting colder. Scientists started calling this cold patch the cold blob. It sits right in the path where the warm ocean current is supposed to flow. At first, experts expected this to be just a temporary glitch caused by natural weather cycles. Ocean currents naturally speed up and slow down over short periods, so many believed the system would quickly balance itself out. But as year after year went by, the cold blob did not disappear. In fact, advanced satellite readings and deep-sea probes showed that the giant current was continuing to lose power at a rate nobody thought possible. When scientists investigated what was causing the slowdown, they discovered a startling truth. Massive glaciers and ice sheets in Greenland are melting at record speeds because of rising global air temperatures. As that land ice melts, billions of gallons of pure, fresh water rush directly into the North Atlantic Ocean. Fresh water is much lighter and less dense than salty ocean water. Because this huge blanket of fresh water sits on top of the ocean, it prevents the cold water underneath from sinking down to the seafloor. Without that sinking action, the giant underwater conveyor belt cannot pull new warm water up from the equator. The pump is basically losing its suction, causing the whole system to jam up like a clogged pipe. Did you realize that melting ice could actually make parts of the world colder instead of warmer? Drop a quick comment down below letting us know if this surprise connection makes sense to you, and hit the like button if you want more people to discover these incredible science stories. This gap between expectations and reality matters because even a small change in ocean currents causes massive shifts in regional weather patterns. In recent times, Europeans have started feeling the early warning signs of the system breaking down. Instead of smooth, gentle seasons, the weather across the continent has turned chaotic, jumping from one extreme to another with almost no warning. Look at what happened during recent summer months. Experts originally expected heat waves to increase gradually over many decades, giving communities plenty of time to adapt. But what actually happened smashed all historical records into pieces. In June 2026, Western Europe experienced its hottest June in recorded history, with temperatures soaring past 40 degrees Celsius in countries like Germany, Poland, and the Netherlands. In the town of Noto in Sicily, Italy, the temperature reached a staggering 46.5 degrees Celsius, which is over 115 degrees Fahrenheit. That is hot enough to melt asphalt on city streets and overwhelm power grids as millions of air conditioners run at full blast. In the United Kingdom, weather stations recorded 3 consecutive days of red alerts for extreme heat, a level of danger never seen in that nation's history. Why does this extreme heat connect back to the slowing ocean current? When the ocean conveyor belt slows down, warm tropical air gets trapped further south or gets pushed north in violent, unnatural heat domes. The normal flow of weather systems across the Atlantic gets blocked, causing stubborn weather fronts to park themselves over Europe for weeks at a time. The heat has nowhere to go, baking cities until the air feels like an oven. Before we look at the next surprising reveal, here's the detail that researchers say is most shocking of all. Europe is warming twice as fast as the global average, making it the fastest warming continent on the entire planet. This means every shift in ocean dynamics hits European nations harder and faster than almost anywhere else. The repeating pattern of scientific surprise does not stop with summer heat waves. Consider what scientists originally expected for European winters as global temperatures rose. The standard model suggested that as the planet warmed, winters would simply get milder and milder, eventually making snow a rare sight in major cities. But what is actually happening is far more terrifying. As the main Atlantic current grows weaker, the protective shield of warm air over Europe begins to fade away. This allows freezing polar air from the Arctic to spill southward, plunging regions into sudden, intense cold spells. Scientists at major institutions like the University of Miami have found that a weak ocean current creates unstable atmospheric jet streams. Instead of blowing in a straight line from west to east, the jet stream starts to wobble like a loose tire on a fast car. When it wobbles south, it drags brutal Arctic frost straight down into farmland and towns that are completely unprepared for deep freezing conditions. Farmers across Central Europe have watched young crops freeze overnight in late spring, destroying harvest yields and driving up food prices for everyday shoppers. The gap between a simple warm winter forecast and the reality of erratic, icy blasts shows that global warming does not mean uniform heat everywhere. It means the planetary air and water systems that keep life stable are losing their balance, leading to unpredictable wild weather. If you were put in charge of preparing a major European city for both 115-degree heat waves and minus 20-degree winter freezes, what step would you take first? Tell us your strategy in the comments, and don't forget to subscribe to stay updated on how extreme climate shifts are affecting our world. To see how credible and grounded this research is, we can look at the real-world data gathered by top organizations. Teams of international marine experts use specialized ocean monitoring arrays like the RAPID network and the OSNAP system. These networks consist of dozens of deep-sea anchors, mooring lines, and floating sensors stretched across the North Atlantic between Canada, Greenland, and Scotland. These sensors sit thousands of meters below the waves, constantly measuring salt content, water speed, and temperature. Data collected over 20 years shows that the strength of the main current has dropped by a measurable margin. To give you an idea of how much water we are talking about, this single current system normally transports over 15 million cubic meters of water per second. That is more water than all the rivers in the world combined. When a system of that size slows down by even 5 or 10%, the energy shift is massive. It is equal to the energy of millions of nuclear power plants shutting off all at once. The World Meteorological Organization, along with climate centers like the Copernicus Climate Change Service in Europe, tracks these numbers daily using Earth observation satellites like the Sentinel-3. Satellite photos show that land surface temperatures in Europe during recent heat events reached levels normally seen in northern Africa or the Middle East. Soil was so dry and hot that it could no longer absorb heat, creating a feedback loop where the ground cooked the air above it day and night. The next critical fact to keep in mind is something that leaves even veteran oceanographers speechless. Computer models show that if this current slows past a certain tipping point, it cannot easily turn back on. Once the freshwater disrupts the delicate balance of salt and cold, the pump shuts down and stays weak for centuries, completely altering life across the northern hemisphere. Right now, we are witnessing a dramatic shift from past predictions to what is happening right this second. This is no longer a distant theoretical model about the year 2100. The dramatic turn in Europe's weather is happening in real time, with consequences unfolding right before our eyes. In major countries like France, Germany, and the UK, thousands of heat-related deaths are recorded during peak summer months. Hospitals are seeing spikes in admissions as emergency services scramble to care for vulnerable residents. Water levels in crucial economic rivers like the Rhine and the Danube drop so low in summer that massive cargo ships cannot float, stalling global trade lines and shutting down factories that rely on water cooling. At the exact same time, the developing weather patterns are creating severe rain and storm events in other parts of the continent. Atmospheric rivers, vast plumes of moisture carried over the sea, are slamming into southern Europe, causing sudden flash floods that sweep through historic towns and wash away precious topsoil from agricultural lands. The situation is actively evolving every single month as giant climate drivers like El Niño intensify in the oceans. Scientists at the World Meteorological Organization report that a strong El Niño pattern is currently pushing global sea surface temperatures to near record levels, adding even more energy to an already unstable system. To understand how deep this problem goes, we have to examine the history of the North Atlantic Ocean itself. thousands of years ago, near the end of the last major ice age, our planet experienced a sudden and violent climate event known as the Younger Dryas. During that period, a gigantic lake of fresh meltwater in North America broke through an ice dam and poured into the ocean. Scientists who study ancient ice cores from Greenland discovered that this massive influx of fresh water shut down the Atlantic Ocean current in a matter of years. What followed was a sudden plunge back into near glacial cold that lasted for over 1,000 years across Europe and North America. Forests turned into tundra, and early human populations had to adapt rapidly just to survive the freezing conditions. For a long time, modern geologists believed that such a massive shutdown could only happen during the transition out of a major ice age. They assumed that our modern climate was far too stable for such violent shifts to occur ever again. But recent ice core data and ocean sediment samples prove that assumption completely wrong, showing that the ocean engine is far more sensitive to freshwater disruptions than anyone ever dared to imagine. Have you ever heard of the Younger Dryas period before today? Or is this ancient climate history completely new to you? Let us know in the comments below and share this video with anyone who loves learning about forgotten history and earth science. When marine researchers pull long sediment tubes from the sea floor, they can read the history of ocean currents like pages in a history book. Tiny shell creatures that lived millions of years ago fall to the ocean bed when they die. By measuring the chemical marks inside those tiny shells, scientists can recreate exact ocean temperatures and salinity levels from thousands of years in the past. What these deep-sea samples reveal is a repeating pattern of fragile balance. Every single time fresh water flooded the North Atlantic in large amounts, the conveyor belt slowed down, and European weather took a sudden, dramatic turn. What was once thought to be an impossible movie scenario turned out to be a well-documented scientific reality that has happened multiple times in Earth's long past. This historical evidence completely changes how we view our modern weather changes. It shows that our planet does not always change slowly over thousands of years. Sometimes, the climate engine reaches a sudden snapping point where conditions flip from one state to another in less than a single human lifetime. Understanding this ancient pattern helps explain why oceanographers are watching current freshwater levels so closely today. The Greenland ice sheet holds enough frozen water to raise global sea levels by over 20 feet if it melts completely. But long before that sea level rise happens, the freshwater flowing off Greenland could permanently disable the ocean pump that keeps Europe livable. To track these freshwater movements, scientists use advanced autonomous underwater robots called gliders. These torpedo-shaped drones dive deep into the ocean for months at a time, collecting data on saltiness and temperature at various depths. The gliders send their findings back to research hubs via satellites every time they surface, giving experts a live 3D map of the North Atlantic Ocean. The latest measurements from these deep-sea gliders confirm that fresh water is not staying near the coast of Greenland. Instead, vast currents of meltwater are creeping directly into the ocean zones where deep water sinking normally occurs. The boundary layer between warm, salty surface water and cold, dense ocean water is shifting in ways that match the early stages of past historical slowdowns. Are you surprised by how much technology scientists use to measure ocean currents deep underwater? Drop a comment down below to share your thoughts on these autonomous ocean gliders, and hit that subscribe button to join our community of science enthusiasts. Now let us look at what this means for human infrastructure and city planning. Cities across Europe were built over centuries to handle specific weather conditions. Roofs in Scandinavia are designed to hold heavy snow, while buildings in southern Europe are built with thick stone walls to keep out heat. But almost no city in Europe was designed to handle both extreme Arctic freezes and scorching desert heat waves within the same single calendar year. In northern cities like London, Dublin, and Amsterdam, houses are heavily insulated to keep heat inside during cold months. When extreme heat waves strike, these homes turn into dangerous heat traps because very few residential buildings have built-in air conditioning. During peak summer, indoor temperatures can remain painfully high even through the night, preventing body recovery and putting immense strain on public health services. Conversely, in southern countries like Spain, Italy, and Greece, public infrastructure is built around warm weather. When sudden Arctic air sweeps down from a broken jet stream, roads freeze over, water pipes burst, and heating systems run out of fuel. The economic cost of repairing damaged roads, power grids, and water systems after these rapid shifts runs into tens of billions of dollars every year. The agricultural sector faces an even greater threat from these sudden weather fluctuations. Crops require predictable soil temperatures and regular rainfall to grow and produce food. When a spring heat wave trickles into a sudden late frost, entire orchards and crop fields are destroyed in a matter of hours, threatening local food security and raising grocery prices across global markets. Before we move on to what this means for the global future, here is the detail that leaves economic experts most concerned. The financial damage caused by unstable weather patterns in Europe could soon outweigh the total cost of transitioning the continent to clean, sustainable energy sources. Preparing for chaotic weather is far more expensive than preventing the climate engine from breaking down in the first place. When we shift our perspective from Europe to the rest of the world, we see that the consequences of a slowing Atlantic current extend far beyond one single continent. The global ocean is one giant connected system, often referred to by oceanographers as the global ocean conveyor belt. What happens in the North Atlantic ripples through the Indian Ocean, the Pacific Ocean, and even the icy waters surrounding Antarctica. For example, when the Atlantic current slows down, heat that would normally travel north remains trapped in the tropical Atlantic Ocean. This extra energy warms up the surface waters near the equator, providing fuel for stronger and more destructive hurricanes in the Caribbean and along the eastern coast of North America. Warmer tropical waters mean storms can intensify much faster, turning mild weather systems into Category 5 monsters overnight. In addition, the shift in thermal energy disrupts global wind systems like the monsoons in India and Southeast Asia. Millions of farmers in Asia rely on predictable monsoon rains to water their rice fields and sustain their families. If the Atlantic current weakens significantly, monsoon rain belts shift southward, leading to widespread drought in regions that depend on seasonal rains for their primary food supply. In the southern hemisphere, the weakening of the North Atlantic pump alters deep ocean circulation near Antarctica. Cold bottom water from the south begins to move differently, affecting nutrient cycles that support marine life across the entire Pacific Ocean. From tiny plankton to giant blue whales, sea creatures depend on these nutrient currents to find food and raise their young. What do you think is the most alarming potential impact of this global weather disruption? Tell us your thoughts in the comments section below, and do not forget to share this video with friends who care about the future of our environment and global food supplies. To really grasp how these changes affect day-to-day survival, we must look closer at the delicate relationship between ocean temperatures and local marine life. For thousands of years, the cold, nutrient-rich waters off the coast of northern Europe supported some of the richest fishing grounds on Earth. Cod, herring, and mackerel migrated along predictable routes, feeding millions of people and providing livelihoods for coastal communities. However, as the warm Atlantic current slows down and fresh water spreads across the surface, the marine ecosystem is experiencing a massive shock. Cold water species are being forced to migrate further north toward Arctic waters in search of suitable temperatures and food. At the same time, warm water invasive species from further south are moving into areas where they never existed before, disrupting local food chains. Fishermen in countries like Norway, Scotland, and Iceland are pulling up nets with completely unfamiliar catches, while traditional fish stocks are declining rapidly. Marine biologists report that fish populations are struggling to adapt because the temperature shifts are happening over years rather than over millions of years. When top predators lose their standard food sources, entire fisheries collapse in domino-like fashion. This collapse of traditional fishing areas creates severe economic stress for coastal villages that have relied on the sea for generations. Processing plants are forced to close, fishing fleets remain docked, and local economies face sudden hardship. The loss of stable marine food sources also forces nations to import more food from overseas, putting even greater pressure on global supply chains. Here's another alarming detail that researchers have recently uncovered. As surface waters grow less salty from melting glaciers, the ocean loses its capacity to absorb carbon dioxide from the atmosphere. Normally, the North Atlantic acts as a massive natural sponge, storing billions of tons of carbon deep below the waves. If that ocean sponge stops working efficiently, carbon dioxide remains in the atmosphere, driving global air temperatures even higher. This creates a terrifying self-reinforcing loop that climate scientists refer to as a positive feedback mechanism. Warmer air melts more Greenland ice, which dumps more fresh water into the ocean, which further slows down the conveyor belt. As the conveyor belt slows, the ocean absorbs less atmospheric carbon, which makes the air warmer, melting even more ice. Breaking out of such a loop requires immense energy drops that are unlikely to happen naturally anytime soon. Did you know that oceans absorb more than a quarter of all human carbon emissions every single year? Let us know in the comments if you realized how crucial sea salinity is for keeping our atmosphere clean, and hit the like button to help spread awareness. What does all of this mean when we zoom out and look at the bigger picture? It can be easy to view ocean currents and weather reports as abstract scientific numbers that only matter to academics, but the truth is that this ocean system is the invisible heartbeat of our global living space. If Europe's weather continues on this dramatic turn, the ripple effects will reach every corner of the planet. Europe produces a huge portion of the world's food, machinery, and technology. If extreme weather causes crop failures, power grid collapses, and economic disruptions across European nations, the price of food and everyday goods will rise everywhere. Furthermore, the same Atlantic current system that regulates Europe's weather also controls rain patterns in the tropics. If the current weakens further, the tropical rainfall belt shifts south, causing severe droughts in places like Western Africa and Central America, threatening the food and water supply for billions of people. This interconnected system reminds us that we all share one single fragile planet. The choices we make, the energy we use, and the way we monitor our world directly impact the delicate systems that keep human civilization thriving. Understanding these changes is not just about satisfying our curiosity, it is about preparing for the future and protecting our global home. Scientists are working day and night to deploy new deep-sea probes, launch advanced weather satellites, and build better climate prediction tools so that communities can prepare for whatever comes next. Knowledge is our best defense against an uncertain future, and staying informed is the first step toward finding real solutions. If you found this breakdown eye-opening and want to stay updated on the most important science stories happening right now, make sure to hit that subscribe button and turn on all notifications so you never miss an upload. Drop a comment below answering this question. Do you think our society is doing enough to prepare for these sudden weather shifts? Share this video with a friend or family member who loves space, science, and the mysteries of our Earth. Thank you so much for watching. Stay curious, and we will see you in the next story.